So this is a really advanced talk about security. If you don't know what a cross-site request forgery attack is, or you've never heard of cross-site scripting or SQL injection, it's going to be very difficult to follow. So hopefully people have self-selected into this talk. And the rest of you can hold on for dear life. So my name is Bryan. I started a company called Code Climate. So this is the quick ego boost for me. How many people have heard of Code Climate? Awesome. And how many people have actually used it, open source or otherwise? It's pretty good. The rest of you guys, we'll talk later. So security researchers will sometimes say this: insecure by default is insecure. And what they mean is, if a programmer has to take an action every time they write something in order to create a secure behavior, then it stands to reason that eventually the programmer will forget to do that. So over a long enough period of time, if you have an insecure default, you end up with an insecure system, right? So we prefer secure defaults, where if you don't do anything, it's secure, but you have to go out of your way to shoot yourself in the foot, which we all will do eventually, but we give ourselves more time. So we'll start with a survey. How many people believe this statement is true? Rails is secure by default. Raise your hand if you believe this is true. Few people. You guys are good. How many people believe this is false? OK, yeah, because you're in a talk called Rails and Secure Defaults. So at least you're paying attention to what room you're walking into. Rails is actually very secure by default. Rails does a great job. For my money, it's probably one of the most secure web application frameworks you can pick off the shelf and code with today. There's a lot of stuff in here that you're not going to get if you're programming in frameworks in other languages. And even if you're using Sinatra, which is much more bare bones, it doesn't do a lot of this stuff for you. So you get a lot of protection against SQL injection vulnerabilities by way of the active record API. You get protection against cross-site request forgery attacks in the action pack layer. That's been around since Rails 2. And cross-site scripting attacks, which dropped in Rails 3. You get a lot of protection against that out of the box with Rails. So it does a lot of work, and the people who are working on Rails security care a lot about making sure your app stays safe. But today, I want to talk about insecure defaults. And what I mean by that is not, this isn't going to be groundbreaking Rails vulnerabilities that are going to go up on Hacker News and get 1 million upvotes. That's not what I'm going to do today. I want to talk about some areas where I believe Rails could have more secure behaviors and raise awareness about these issues. So if you're coding your applications, you can make sure you don't fall into these pitfalls. And maybe even spur some discussion within the community about whether Rails should change some of these behaviors to be more secure. And in the best case, if somebody writes a pull request to fix something that I cover in my presentation, I'd love to hear about it. And I think that would be the ideal outcome. So we'll start with some small, simple security risks that I believe Rails has out of the box. Verbose server header. So HTTP responses include a server header that usually refers to the software that was used to generate the response of the request. In this case, it's Webrick 131. And it also includes some information about the Ruby version. So you see it's Ruby 193. There's also a date. That date corresponds to the release of patch level 194. So from that server header, you know exactly which Ruby version, and patch level is running on that server. Now, who cares? Security by obscurity is not security. So why do I care if I just tell everybody what version of Ruby I'm running? And to that, I would say, well, why don't you just give everyone your gem file, too? You can go further than that. Just open source your app, right? So you don't want to expose your Ruby patch level specifically because, for example, spray and pray scanners, it makes it a lot easier for them to attack you, right? A lot of times, if you have an attack payload, you need to customize that based on the software you're attacking. So there might be a vulnerability that affects different versions of Ruby, but you have to exploit it different ways for different versions. You're giving the attacker all the information they need to craft their attack against your server exactly in the way that's necessary to go in and attack your server, create an exploit without setting off any alerts, generating any 500s, anything that might alert you that something's happening. So you don't want to give an attacker this information. So that was a Webrick example. As a best practice, you shouldn't really be running Webrick in production anyway, so don't do that. Use a server like Passenger, Unicorn Thin, Puma. But Heroku users might not realize this, but my understanding is on the latest stack, actually, if you do nothing else, Webrick is going to be your default web server. So this affects you if you're a Heroku user and you're using Webrick, or you haven't chosen another server. So how could Rails fix this? All these examples, I'm going to give you best practices so that you don't get owned, and then some suggestions for how Rails could have better behavior. So the proposed fix, this remote's a little heavy-handed. Proposed fix. Rails could reconfigure Webrick to not include that information in the header. It's an option that you can pass into Webrick. It would be like a one-liner. Okay. Second, we're moving up here. It binds to 0000, which does not mean localhost. It means all interfaces. The problem with this, there's issues with this in production and in development. In development mode, you might have a laptop that at some point, not you, but the guy you work with, maybe he loaded some production data onto his development laptop one day just to help debug something. And then he goes to San Francisco and opens his laptop in a coffee shop. I would love to scan San Francisco coffee shops for port 3000 24 hours a day and root all the applications that are on there and the production copies of the data that have made their way onto those development laptops. So don't do that. But the fact that it's bound to 0000 makes this a lot worse because you can reach those servers even if you're not on localhost. And in production mode, Rails is thought to be unsafe when running in an unproxied configuration. If you ask the Rails core team, they'll tell you that you have to run a proxy in front of Rails to prevent things like IP forgery attacks. If you run an unprotected Rails instance, it's trivial to forge IPs that get logged to the logs by passing a header. So in production, you don't want to run on 0000 because it might allow somebody to access your application directly when you intended them to access it through a proxy, like Nginx or HA proxy. So the best practice, use the -b option to bind to localhost instead of 0000. Avoid loading real data into your development environment. That's a risk anyway for lots of reasons. And if you do, delete it as soon as you're done with it. So it's more general. But the proposed fix, Rails should change the default so that it binds to localhost instead of all interfaces by default. And people who need it to bind to all interfaces can obviously just add the -b flag and change it for their environment. But we can have a secure default behavior. OK. Logging SQL values. Rails has a really nice feature called filtered parameter logging, which will prevent the logging of, let's say, passwords from showing up in your production.log files, even though that's sent in as an HTTP request value. However, if you have SQL logging turned on, it doesn't do anything to that SQL string that gets logged to your file, right? So this is an example of a request, and it's creating a user, it's logging the password digest, and that's showing up in the log file. So anybody who can read the log file could see the password digest and try to brute force that. Why do you care? You might say, hey, we don't run with that log level in production. It's not the default, which is true. But the issue here is that the database does get sensitive values, just like the parameters. Everybody knows that. Filtered parameter logging doesn't apply. But here's where things start to break down. Somebody turned the production log level up to debug an issue one day. Not you, but that guy you work with did that to debug something. And when they did, they didn't delete the log files off the server afterwards. So they made a change, a one-line change to a config file, pushed it, deployed it. Now all of your application processes have started logging passwords to the log files, right? And then it took 2 hours to debug it, and then they made another change and committed it and deployed it again. Did they go delete all those log files afterwards? Your coworker probably didn't. So best practices, be very aware of what you're logging in production, both in your default log level and any log levels that you use for debugging. If you have to increase the log level temporarily, make sure you remove any sensitive data from the logs when you no longer need it. But how could Rails help us with this? What could Rails do, even though it has a good default log level for production, to help us even in this case? And I would propose that it could introduce a config filter logs value, which also affects SQL statements in addition to HTTP parameters. And you could redact the SQL statements if they contain reference to filtered fields, like passwords. The mechanism is basically there in the active record API, now that we've got all this relational stuff, to know when you're dealing with a bound value that is bound to a field like password, and be able to redact those values in SQL statements most of the time. If you pass a general SQL statement just to Rails, it doesn't know what you've given it. It would be very difficult. But for cases where you're composing queries with the active record API, Rails could do something about this. OK, those are the warm-ups. Those weren't that bad. But now I want to move on to like real deal, like hair-raising shit that can happen in your application if you're not aware of the way Rails works. So version secret tokens is a big pet peeve of mine. The secret token RB file gets generated by Rails when you say Rails new. It makes this really easy. Rails helps us out with this. They generate a secure random value, and they drop it in your config initializers directory, which is fine. The problem is that gets committed to version control. It gets deployed to production, and most developers are none the wiser because they didn't even generate that value in the first place. So why would I have to secure it? I didn't have to, like, it's not like I got my Stripe API key where I like go and get it off the Stripe website and put it in. Like, Rails just does that. So what's the issue with that? That secret token is like your app's root key. If you have that secret token, you can trivially forge any session you want, which means you can basically take over privileges of anybody you want. And if you do that, you can basically bypass all of the application level security controls. So it's bad news if somebody were able to get your secret token. And encryption is only as good as the key management. In this case, that token is effectively your key. So if you have that copied on, say, I don't know, 50 developers' laptops strewn around New York City, that would be bad. Because if somebody gets one of those, they can use that secret token and start forging sessions and break down all your controls. So as a best practice, you need to use a different secret token in production than you use in development. That's a bare minimum. You can inject that via an mvar. Heroku makes this very easy. You can use utilities like mvdir to build a system like that yourself. Or you can symlink the secret token RB on deploy if you have a standard Capistrano-based configuration. But what could Rails do better, right? That's what this talk is all about. So Rails, at a minimum, should Git-ignore the secret token RB in the generated app skeleton. This, in my mind, in the current scenario, this is like a no-brainer one-liner that Rails should do. But going a little bit further, and this is an area where I'm interested to see some more discussion, Rails could introduce the concept of a secret store and help solve this problem across the Rails ecosystem. Because you still see library authors, even really knowledgeable ones like the guys at Stripe, when they give you instructions on how to install the Stripe gem, they're just giving you some code that you're basically going to paste into an initializer. And it would be very difficult for them to explain how to do that in a secure way, so you're not actually keeping your Stripe private key in version control. But if Rails creates a secret store, then all the library authors and Rails itself could use that for pulling the sensitive values out. And your operations people can worry about how to manage where the actual storage of that secret stuff is. Like Heroku could do it a different way than EngineYard, for example. So Rails is in the place to provide an API. OK, offsite redirect to. You've seen code like this before? This is a signups controller. And after you sign up, it's going to direct you to a particular destination, maybe back to where you were after you sign up. So you have a params destination, and you redirect somebody back. The problem with this is that an attacker can control the destination parameter, and they can send users to whatever URL they want. That could be a malicious site. You could phish the user. Because if you log into your bank's website, you might be trained to look at the URL bar to make sure it says wellsfargo.com before you log in. That's good. But are you looking at it after every single page load after to make sure that Wells Fargo didn't redirect you to a phishing site? Probably not. And we're developers, so this is really risky for even like average people. So if you send someone to a malicious site inadvertently, it looks like you sent them there. You incur all the reputation damage. And unprotected redirects are actually significant enough where they've made their way into the OWASP top 10 critical web application security risks for just these reasons. There's some other nasty stuff you can do as well with like cross-site scripting via the page that gets generated that says we're going to redirect you to this, and that link could have cross-site scripting in it. All sorts of gnarly stuff. So what can you do about this? Pass the only path true option, which most people don't even know about. I didn't realize it until a few months ago. You can pass the only path true option to redirect, which will require that redirect keeps you on the same domain. And if you have to take a user's string, that's a URI, for, let's say, any part of your application you're going to send them to, you can run that through URI.parse, and then take the path component off of that and pass that to redirect to, which protects you from a malicious user sending in a different host, right? So that's what you can do. But Rails could do better. Rails should only allow redirects within the same domain by default. That's the 98 or 99% case. Redirect to some other page on this website. In fact, that's almost the only thing we do. It's hard to even think about cases where people do other stuff. But that should be what Rails allows out of the box. And then if you need some sort of insecure behavior, you could opt into it. So it's not the default, but it's available. Maybe you pass a flag like external true to redirect to allow that in the cases where you actually need to direct somebody to Facebook. OK? The next one is link to with JavaScript. So this is kind of interesting. Maybe you're running a social network, and you let somebody enter a string as their public site URL, their profile URL. And you're just going to provide a nice link back to that user's site from your site, right? Simple functionality. The problem is, if the user controls public site URL, they can put a value in that starts with JavaScript : and then whatever the heck they want. And if someone's visiting your site and they click that, that JavaScript's going to be executed by the browser. Rails cross-site scripting protection will not affect this case at all. It's not going to save you. And because it's a cross-site scripting vulnerability, all of the usual disclaimers apply. It's not immediately obvious. I imagine some people were surprised to even see that. It's not immediately obvious you can put JavaScript into a link to and have that behavior happen, because we've all moved on to unobtrusive JavaScript techniques. We're not doing that ourselves anymore. We have to remember back when we used to do that ourselves, but Rails still allows it. So it looks relatively safe, but it has this very dangerous behavior. Cross-site scripting is extremely dangerous because you can steal cookies, you can take actions that the user didn't expect. So as soon as you can get a cross-site scripting vulnerability in place, you're in big trouble. So the best practice would be don't allow unsafe input to control the href values that you passed a link to. Run the input, if you have to, run the input through URI.parse and sanity check the protocol on the host. I bet you're only supposed to be allowing HTTP or HTTPS URLs, not Gopher URLs or arbitrary JavaScript. So you can sanity check that with URI.parse. The proposed fix, though, for Rails is Rails could change link to only allow HTTP, HTTPS, maybe mail to hrefs by default, and those are generally considered safe. You're sending somebody to somewhere else. And if it needed to, it could provide, again, an option to opt into riskier behavior of allowing JavaScript or other potentially dangerous protocols through. That would be a more secure default that Rails could do for us. OK, SQL injection. So the first thing to get out of the way is that Rails is not a silver bullet against SQL injection. Most people feel like, I felt like this way back in the day, that as long as I'm using active record, I'm safe from SQL injection. It's building the queries for me. It's all good. But let's look at that a little bit. So pluck. Pluck is a new active record method that is intended to allow you to pull a series of values off of a given relation. So maybe you have an orders table, and you want to pull back all the subtotals in an array. Active record pluck is a convenient way to do that. Here's the problem. Pluck takes a column name argument. But if you pass arbitrary SQL into column name, it generates queries with no protection. So that column name is actually a SQL fragment. And by taking this order pluck example and crafting the parameter for column name, you might think, OK, this is not safe code. And that's true. You might think, maybe if I write code like this, a malicious user could pluck whatever values, whatever column off the orders table that they want, right? Maybe they could pluck subtotal or total or shipping date, anything like that. That would be the extent of the vulnerability. But it's actually much more severe than that, as you can see, because I can craft a string that's going to cause it to pluck all of the passwords off of the users instead. So that's not expected. And this goes on and on. Calculate, in this case, you would think, OK, maybe I could just sum different columns based on this query. But in fact, because of the calculate API, it's going to inject that SQL fragment and let me pull, in fact, actually specific values off of specific records in a different table. Follow that? So a lot of active record APIs allow some form of SQL fragments to be sent in, where if an attacker can control them, you're going to have issues. Now, there's a great website called rails-SQLi for SQLinjection.org. It was set up by some of the good folks on the Twitter security team, and it basically covers all of these APIs and API options and what the potential risk is for letting an attacker control the value that gets sent in. So obviously, you care about this because it's SQL injection, and people kind of understand that that's a problem. But we care about this also because it's not obvious which APIs are vulnerable, right? Like I said, that pluck argument is called column name. So it seems safer than it is. And some APIs violate, in this case, the principle of least privilege or the principle of least surprise. Right? You might be surprised by the behavior, and it might allow you to do more than it should. So you have to understand which active record APIs you're using and how they might be dangerous. Use the safest AR API, usually the highest level AR API possible for the operation you're performing. And then you can whitelist expected inputs, right? So if you're expecting either subtotal or total as the column name, then whitelist that. But Rails might be able to do better. I would propose that Rails only permit SQL fragments in the API where they're commonly used. So perhaps that pluck example should only accept column names. In fact, the fact that the argument name is column name implies that that's how it's usually used. Avoid attribute names that imply safety when it's not safe. And provide, make the core APIs more safe and potentially provide alternative, more risky APIs for power users who need to drop down to the bare metal and do things which are riskier. OK. YAML serialization. It's a security talk at RailsConf in 2013. It would not be complete without some reference to YAML. So here you go. Serialize and store are two helpers that are available, or kind of macros available in the Active Record API. They'll take data, serialize it, and then store it in a single column on your records. The problem is that YAML is eval in disguise. It's like a transformer. We learned this when Rails had this very high-profile YAML parsing vulnerability in its parameter parsing layer. And it's, to underscore this point, shout out DHH. So would you store Ruby in your database and eval it when it came out? Probably not. But that's what you're doing if you store YAML in your database and you deserialize it out the other side. That's exactly the same thing in terms of attack vector. So don't do that. So why do you care about this? It looks like it's safe to the untrained eye. So you're like, oh, it's just YAML. Like I've got some hashes and some arrays. I know how this works. It's a Unix system. I know this. And then it just goes into the value. And then, but an attacker comes along. They're like, oh, this is YAML. This means I can eval stuff. And then you're screwed. So this is obvious to a lot of us in this room today because of everything that happened in January. But what about the person who comes along and learns Rails next month, who never had this experience of this high-profile YAML vulnerability? Are they going to know about the risks involved? And you don't want a case where you can springboard the injection of a single value into your database into a full-scale box ownage, right? Where if I can, maybe through some other database connection or something else, get a value in, get the Rails app to deserialize it, and then take over the box. That would be a problem. You don't want that. So it's clearly a violation of least privilege. So as a best practice, you can use JSON as the serialization format instead of YAML for the serialize and store macros. And also be cautious of storing YAML-encoded data in things like intermediate stores, queues, your caches, delay job, whatever. If you're serializing things with YAML or Marshall, because Marshall has all the same problems, then you're basically giving anybody who can control those values a way to execute arbitrary code in your processes when you go and deserialize it or unmarshal it. So again, how could Rails fix this? Rails could change the default serialization format from YAML to JSON. And I would advocate that they do this. That would be much safer. And then take the YAML behavior and make that available as an option, or even just extract it into a totally separate gem, because it is less safe than using JSON as a serialization format. OK. So that was a bunch of stuff I threw at you really fast. I hope that this talk can serve as like a springboard for a conversation in the Ruby community about areas in Rails where maybe we've been kind of complacent with the current behavior. You could say, well, we knew these things were risky, but I really want to push us on, can we do better? Clearly, the stakes are high, and we want to create the most secure framework that we can to give developers a leg up in writing applications that don't have security risks. So that's the goal. I'm Bryan. I work at CodeClimate. Thank you for your time and attention, and hopefully we have some time for Q&A. How much? Cool, I've got 15 minutes. Yes?
Does CodeClimate help do any of this stuff?
I see I've got my shill in the front row. The question was, does CodeClimate help with any of this stuff? So CodeClimate does have some functionality to help you get a handle on places where your application security might be weaker than it could be otherwise. We have a feature we call Security Monitor, which scans your source code looking for either dependencies that you have that might be vulnerable. So for example, if you have the Rails version installed that's vulnerable to the YAML deserialization attack, we will be able to, say, email you about that if you have a new app that you stand up that has that dependency, or if you've got, you're taking, like let's say that example, params column, and you're passing that to pluck, CodeClimate will actually be able to send you a warning via email as soon as that code gets introduced into your code base before it reaches production. So that's my plug. If you haven't tried it, we really think that it can help out in some of these situations. It's not a magic bullet, but it can be a way to raise awareness and flag some certain things. And that's all I'll say about that, but you're welcome to talk to me about CodeClimate afterwards. Other questions? Yes?
Any thoughts on improving input validation?
Input validation. So how could we improve input validation? What do you mean by that?
Make it less error.
Are you talking about the types? What's that? Yeah. So so I had some stuff in here about strong params, but I took it out because I was a little short on time. The strong parameter stuff is actually really good. It's a pretty recent development. I'm a big fan of that approach for dealing with, for example, protection against mass assignment. But and somebody start yelling at me if I'm actually like if any of this is incorrect. But strong parameters has also grown, I think, to include some protection against certain data structures or types coming into from your controller layer that are unexpected. So if you're expecting a scalar value like a string and somebody passes in a hash, and that might, for example, cause active record to query something in a way different than what you expect, strong params can help with that. So as far as input validation, there might be other behaviors that could be added to make things more safe, and that would certainly be something to talk about. But the strong params gem, which is actually now a default feature of Rails 4, is exactly where I think that stuff should live. Obviously, there's limits to what Rails can do, being a framework, understanding your domain and what's supposed to be coming in. But if there are ways to secure that behavior more, then strong params is the answer. Yeah, I got a question in the middle. Speak up.
Just to kind of add on to that, checking inputs, Ruby has the tainted feature.
Yes.
Any thoughts on Rails using
So the question is, any thoughts on Rails using the taint feature, which is built into Ruby? I have not actually heard of cases of people in the wild using taint in Rails apps or web apps successfully to add an additional layer of protection. If anyone has does anyone know of anybody who's done that, used taint to help secure their app? Okay, I had no hands. So I think it's an interesting idea to explore, but to date, I think there might be some issues with the implementation of taint as it stands right now. In terms of the usability of that sort of in practical usage today. So I think that might be why it hasn't been used. Yeah?
Whether it be just general web stuff, Ruby or Rails, what would be like one book that you would recommend is like the most advantageous to read?
Good question. So I'll give you my shill answer, and then I'll see if I have a real answer. One more thing. Hey, railssecurity.com. So that's going to be, I did not communicate with that guy ahead of time. So I'm working on a book which is about this sort of stuff. It's about Ruby and Rails and web application security and attack vectors and ways like countermeasures that you can employ to prevent your application from getting hacked. It's free. It's Creative Commons licensed. It's not done. So if you go to this page, you're going to get an email address collection form. But the more people that put their email address in on that, the faster I will finish it. So if you like this content, I'm not selling it. It's totally free, Creative Commons. But if you give me your email address, that will help motivate me. So that's one answer. As far as books that, or content resources for Rails and Ruby security in general, there is a Rails security book that was published by the Pragmatic Programmers a while ago. But the problem is this information tends to decay fairly quickly. So it's not up to date with a lot of the advances. So I think it's very difficult for a book about Rails security to stay current. Like the dead tree print process is not optimized for that kind of thing. The Rails security guides are very good. There's a Ruby security reviewer guide that was published by Google that Ilya Grigorik helped out with, which is pretty good. But there's no, as far as I've seen, there's not one resource that you can go to which has all of this stuff, which is why I'm trying to, this is the void I'm trying to fill with the ebook in particular. So there's that. Other questions? OK. So one more thing. Code Climate is doing free application security checkups out of the exhibit hall tomorrow and Wednesday during the breaks out of the Blue Box booth. So if you have an application, you can bring it, and we'll run some automated scans against your app, see what they come back with, and I'll be there as well as some other folks who are knowledgeable about this kind of thing to basically help you figure out what you should focus on first, where the big issues are, and just talk through with you your risks and a plan for moving forward. So we're doing that for free during the breaks Tuesday and Wednesday, so please drop by for that. That's all I've got. Thank you very much for your time and attention.